Wow. Okay.
Click on something that says okay at the top.
Okay, you're on.
I
Yeah.
think I'm on. I think we're ready. I got my bright red old beret on, and my name's Ron. And again, welcome, one and all, to our big weekly podcast. We'll throw in some Zoom video and call it a vlog. We do call it the SBAU Astro Hour, everybody, for the South Central California coast's longtime astrophysics and telescope club, the Santa Barbara Astronomical Unit, everybody. I'm your proud MC host, Vice President Ronnie Herron, about to help board the weekly cosmology road trip. And we're going to meet the commander and everybody. It's like a Class A course in physics every week out at UCSB's Broido Hall. Introduce you to the professor who runs things and the other club members in a moment. For now, just know we're proudly centered out at the beautiful Santa Barbara Museum of Natural History. And you can learn all about us at sbau.org. And this is our 191st episode. Please tell your stargazing friends about us. It's for October 21st through the 27th. Here's what we're going to talk about this week. In our astronomical soap opera, we find winter slowly replacing summer, with Deneb pushing Vega toward the west, taking its place as the zenith star. Welcome to Guiding Light, everybody. Halloween's approaching, and Arcturus takes on the role of the ghost of summer suns. This Friday, Venus will merge lovingly with Antares. The great square of Pegasus looks more like a diamond. Say goodbye to Church-and-Shan Atlas. And what's a comet's anti-tail? We're going to find out. We'll tell you. There's a cosmic alignment allowing us possibly to look into dark matter. Plus, 2 European Mars orbiters spied something on the red planet's south pole. And just for the record books, if you watched that incredible video sent from YouTube by way of our president, I'm going to introduce you to Dr. George Smoot and Dr. Martinus Veltman, who won the physics prize, Nobel Prize for physics. I met with some grad students to talk about dark matter, and one of those scientists doesn't believe it exists. Let's meet the gang. Hello, Commander Jerry Wilson, our beloved president.
Good morning.
Going to be running again in 2 months for president. His lovely wife, Pat Forgy. What's that? What were you saying? Did I interrupt you?
No?
Nope. Don't want to interrupt the captain. I consider myself either Scotty or maybe Mr. Spock on board the starship. Here's Chuck McPartland, also married to a Pat, Santa Barbara Outreach Coordinator, still supporting Ukraine, as we all are. His wife, Pat, is in the other room. The cats are with him. She's merchandise manager, and our beloved treasurer, Tom Whittemore, joined us, editor of the Santa Barbara Astronomical Unit monthly newsletter, for which the president has yet to, you know what you ought to do, Mr. President, is just summarize the latest things happening. That's why our science is so popular. It's right behind medicine, but medicine and health are a lot more serious. We got the fun science going for us. Tom's married to Maureen. She's retired. Bruce Murdoch's not with us this week, but Tim Crawford's jumped on board.
Howdy.
Telescope expert. Married to Karen. We always start every show. This is being our 191st, 3.5 years into the Astro Hour, with silly science cartoons sent to all of us. And if I can remember where they are, I got about 8. We'll see how many you can call up, Commander Wilson. All right. This one I didn't get. Can you enlarge it at all?
I don't know.
They're talking inside. Is that a CERN collider or just a laboratory? He says to her, the news says physics Nobel Prize for 2024 was awarded. Oh, it's AI. AI, he says, has become out of control, honey. I bet it manipulated the Physics Nobel Committee and awarded the prize to itself. And she says, oh my God. That's true. That's a thought provoker, that one.
A new conspiracy theory is born.
Yeah.
That's true. AI is the subject of about half your cartoons. Here it is. The guy's talking to his AI computer. He's a college kid up at Santa Barbara City College. And with his, I guess, essay. Says, no one will suspect. He says it this way. No one will suspect I threw in some typos and bad formatting. I used to grade those papers. I used to grade them. Here's another guy talking on a distant planet to his rolling rover AI. Mission report. I guess the machine says back, there's nothing out there, just rocks. And the astronaut says, yeah, we're here to analyze the rocks. And the machine goes, oh. And he says, you're called rock analysis robot. And the robot says, oh, I didn't know. This changes everything. Really? Robot. Florida decided to move the state. They're not wanting to move here, all those retirees, but enough was enough. 2 hurricanes, and that's
Yeah,
what
you notice it's missing down here. And
yeah,
it's here
right.
between
It'll look like that in a couple of 100 years anyway.
about 100.
100 years, you think you're going to give
Yeah.
them? Okay, well, we'll be left with the only spaceport.
The way
Yes.
I characterized it to a friend of mine in an email is the 15-foot storm surge that Florida experienced this last storm is going to be a permanent sea level about 100 years from now.
Oh,
Wow.
no kidding. What? So it was the worst. Helene was worse than Milton, wasn't it? This is funny. This one I love. You're going to have to blow it up a little bit. Uh, is this the Lenny one? Yeah, back when we used to huddle together inside these chilly giant observatories and look through the end of the scope, a group of astronomers have huddled, and the one guy in charge says, yeah, you'll get a chance to see the new galaxy just as soon as I check on my wife, my ex in Utah. What? She's hanging out with that dirtbag Lenny. My God. And she's undressing. Okay, here is an ancient photo taken 65 million years ago of a very concerned reptile, one of the last that didn't survive, going, no, it's incoming. That's not Sushin
So
Shang.
these suits have been real popular as costumes this year. I noticed
Really?
we went to the event Boo at the Zoo just for kids, and there were at least a dozen of these costumes around.
I don't know how they can make them cheap out of satin. The stuff I used to wear, I would freeze my garbanzos off. All right, here's a guy talking to his robot. They're incarcerated, apparently, and he tells his AI machine, you know, it's your fault we were caught. The robot says back, I told you it takes longer to siphon an electric car. Like the Tesla is owned by 2 of our board members. And this beautiful one, I like this one. In fact, I wrote it down because oh yeah, welcome solar protons. This is a sign up there below the Aurora Borealis. You'll love being part of our atmosphere. There's so much to do here. Try forming some water. Is that possible? Is that stuff combined with hydrogen?
Yeah,
It is hydrogen.
Yeah.
It is hydrogen. It's protons, right? Mostly?
Yeah,
Yeah.
but it'll find electrons, don't worry.
You're going to have to make that a subject sometime. Protons coming by themselves are different from electrons that orbit them as atoms, but they're 2 different media going across the. Do they both go at the speed of light or only
No.
electron?
No, they have mass, therefore they don't go at the speed of light.
But electricity, which is electrons, goes at the speed of light, doesn't it? In a
No.
wire?
No,
No.
No.
It
nope.
does. Okay.
Nope.
Lots to talk about. Where would you like to start, Commander? Warp speed, engage. Here we go. Ooh, the night sky descends upon the Astro hour. That's bright spot is Florida leaving the Union. No,
No, this is
the moon.
yeah, this is the morning sky 2 days away, but only the moon will change position noticeably in that time. So at 3 a.m. it forms a nice little triangle with Castor and Pollux here.
And
then
yesterday
Mars
morning, Jerry.
What's that?
I was going to say yesterday morning, about 6:15, 6:30 in the morning, the moon, Mars, and Jupiter made a beautiful scalene triangle near the top of the sky. It's really pretty.
Okay, so that would be way to the left here.
Yeah,
Jupiter is up and to the right.
right. Yeah,
There it is.
there it is.
Right.
So you see how much the moon has, it will move, you know?
Mhm.
Yeah.
Well, my
Anyway, we're transitioning to the winter sky here.
Mhm.
And the winter sky is the sky that has the most bright stars in it and the brightest stars. So that's starting to come in with Orion here
Mhm.
in the morning sky.
Yeah.
A couple months from now, it'll be overhead in the
Yeah.
evening.
I was going to say, Jerry, that same morning, yesterday morning, again, I'm talking around 6:15, 6:30. You could see the belt point to the left to Sirius, and to the right, you could see it point to the Pleiades. Okay. And then just hovering over the horizon, leading Sirius was Canopus. I could see Canopus.
Okay.
Yep.
Up on that hill.
Yep.
Yeah, Canopus is low, boy. I don't even know if I can get that.
No, you have too many trees there, Tim.
Oh, yeah.
Terrain, no, you couldn't get that.
Now, full moon was last Thursday.
Yeah.
So
Mhm.
this is 4 days later. So we're about halfway to last quarter.
Mhm.
So it's still fairly bright. But in this picture, M44 down here is nice.
Mhm.
It doesn't involve a lot of faint fuzzies.
Oh,
Nebula.
the beehive.
Yeah.
Hmm.
Mhm.
See, here's what I don't understand, gentlemen. Back in Carl Sagan's time in the 70s, when they launched the two Voyagers, apparently somebody discovered that all the planets out there, the major ones, were lined up for the Grand Tour.
Yeah. They took
And yet,
advantage of that alignment.
okay, so these days they're not lined up, right? And yet every so often they're lined up. I don't understand
Every
it.
so often, yes, they are. Yes.
Mhm.
But they're in a special alignment that they can be taken advantage of by a speeding spacecraft. It doesn't mean they're all in a perfect line.
Right.
No, but where is Saturn right now? Is it totally in a different part of the sky?
Yes.
Mhm.
Okay, well then that makes sense. It could be
So
on
the
the
only time I knew about planets lining up in a line on the one side of the sun, and I've told you this before, so bear with me, was in 1964. And they had, I think it was April, and the claim was going around on what would have been the internet that California will break off and fall in the ocean.
Mhm.
And
Yeah.
the Daily Sundial at Cal State Northridge had sponsored a Be the First In party at Zuma Beach.
The first hit. Would it be possible to say that since we're all on the ecliptic, which is level with the sun's equator, all the planets sooner or later are going to go behind the sun and not to be visible, right? Do any of them go over the sun or below the
Sure,
sun?
Venus will
Yeah.
do that.
They miss all the time.
Yeah.
Really?
They're
So
not, the ecliptic isn't all that flat.
Yeah.
Oh, okay.
Sorry, I'm having a little glitch here.
Uh-oh. There we
Um,
go. Got
yeah,
it.
the pictures don't come
Yeah.
up in order with this particular
You
display.
know, Jerry, just an aside, I know how much you love going out when the moon's up, but we're in a phase right now with a lot of our outreaches are with the moon up there. And I'm finding that, taking a little scope out with my friend Tom Whittemore here and looking for clusters. They're a
Yeah.
lot better when the moon's full and everything. It's hard to see other stuff,
Yeah.
but the clusters seem to be better.
Yes, and if there's a lot of sky brightness, if the sky's not really dark, then
Mhm.
things like the double cluster, it emphasizes the red giants. They're easier to see.
Oh, okay.
Mhm.
So this is what's called the ghost of the summer sun.
Huh.
So according to Sky and Telescope magazine,
Mhm.
the star Arcturus down here in Budas, which is just about to set at
Mhm.
7 o'clock. So it's not going to be this dark as it shows in this planetarium thing. But this is right where the sun will be, or was 6 months ago at this time. So that's why it's called the ghost of the summer sun.
Huh.
Now I haven't
And
looked through
the
my
comet
planetarium.
right now is kind of over there, would be on the left side of this in Ophiuchus there by
Mhm.
Marfic in that
Oh,
neighborhood.
I see. I am 12.
Yeah. or that's where it was yesterday. I don't know. It's moving quite fast.
Right.
But
Right.
What's moving fast?
disappeared
comet.
to take it
Oh, the
out.
comet.
Yeah. Yeah, we've
Okay.
seen it three nights in a row here. Naked
Yeah.
eye still last night.
Really?
It went from above M5
Mm-hmm.
up this way.
Right. It's going through the base of Ophiuchus.
Yeah.
Yeah.
Okay, we'll come to that in a minute if I get this thing right. You can see this, right?
Yes.
Yes.
Oh,
Okay,
yeah,
good.
yeah. Mm-hmm.
Where the heck does that comet go for 80,000 years? That's crazy.
Goes home.
Yeah.
Well, that's way out in the Oort cloud, you suppose?
Well, that's where you'd be with an orbit like that, or at least Kuiper belt.
Yeah. Yeah.
Yeah, and you can see Venus each night getting closer and closer to Antares over in the
Wow.
southwest. Mm-hmm.
There's Venus, Antares,
Mm-hmm.
very big contrast in color. Now,
Yeah.
this is very early in the evening. You will
Mhm.
just be able to see Venus. You won't be able to see any of this other stuff. This is just showing the positions of it. But where was the Venus and, oh, well, I think we're coming up on that.
Okay.
Let's see where the tab to change pictures is different in each software. I have to hunt for that.
Oh, the Great Square.
Yeah, so this
Mhm.
is the Great Square, as Ronnie said. It's coming up, it looks like a diamond here, but it's still
Mhm.
square. When I went to Australia one year, it was I was the first time I was very confused by the sky. I didn't recognize anything. It's all upside down. It's actually I was upside down. But the Great Square was the starting point, and I figured everything out from there. An
Mhm.
upside down square is still a square.
And what is that, Chuck? It's like a horse and it's cracked in half.
Pegasus.
Yeah, yeah.
Say the rest of it.
Okay, well, he when he was put in the sky, his rear half cracked off and fell back to earth and brought forth politicians.
Mhm.
All four of those stars are in Pegasus?
Not
Yeah.
really.
Okay, but the only asterism we have is just a square. It doesn't
Yeah.
represent a box or anything else.
Alpherat's right here is actually in Andromeda.
Mhm.
It's part of the Great Square. So this faint green line you may not be able to see is the boundary of the
No, we can
copper
see it.
line. What's
We-
that?
We can see that.
I
Okay,
can see it,
good.
Jerry.
Let me know if any of my pictures are washed out, and I'll go to a different
Yeah,
way to
we'll
explain
do.
that
No,
picture.
this is great.
Okay. So
Mhm.
this one up here that I put the cursor on, that is NGC 7331, which is a very nice feature under a dark sky to see. It doesn't have an M number, which surprises me a little bit. But this is the galaxy NGC 7331. And this was taken by Adam Bloch at Mount Lemmon Observatory with their 24-inch telescope.
Mhm.
I think of galaxies as barred or not. But this one is referred to as an unbarred galaxy. I would have just said it's a galaxy, and I would have added the bar for this obvious barred galaxy up here.
Mhm.
But so it's very nice, very oblique view, nice blue for the stars that are out here in the wings, nice yellow orange for the older stars in the core.
And that sort of double tilt look is very reminiscent of the Andromeda galaxy.
Yes,
Mhm.
yes, it
Mhm.
is.
What would we see in a backyard telescope? Well, could we see this?
Yes, you can see this. I've looked at it in my 12.5-inch f6 Newt. And you can see it. It's a faint fuzzy, of course. You have to use averted vision, or at least
Oh, okay. Okay.
So
And there's some smaller ones in the background.
yeah, you won't see, or I didn't see those when I looked at it.
Okay.
What's his name? The guy that Kent. Anyway, the guy who specializes in planetary nebula. He was at Star one year with his 20-inch f5.
Yeah.
Looked at a lot of these things with his scope, and they really pop.
Mhm.
They lose the faint fuzzy look. The only faint fuzzy thing I saw was through his scope, and the first time I ever saw it was Stephan's quintet.
But galaxies don't ever spike like that star at the top, do they?
Oh, I guess not. It has to be really concentrated, and this one is the image, it's saturated, and so it shows up the diffraction patterns. You have not gathered enough light down here to saturate any elements, but it's not the saturation that causes the diffraction spikes. It's just the large amount of light that also causes it.
So if this were a Webb picture, there'd be 6 spikes on that star, right?
Mhm.
At least.
Simply because
Oh, yes, that's right. Yeah, if that were taken by the James Webb.
simply because there are panels that are 6-sided. That's the only reason.
Yes, yep. The
And it has
symmetry.
a three-sided secondary support.
Yep, that's in there too. When you take a picture of the night sky with your DSLR, your regular Canon or Nikon camera, you around the real bright stars, you can get a little radial pattern of spikes going out. And it's because the diaphragm has that many blades in it to define the aperture.
Huh. Didn't know that.
Also, I learned I had a war surplus. Back in the 60s, when I started out, there was a lot of equipment left over from World War II. And some of the things were aerial camera lenses that they used to fly over and take pictures. And I had a 4-inch f6 Aero Tessar lens that was made to cover a 9 by 9 inch photographic plate. I used it on a 4 by 5 cut film plate. And there was a flaw in it. In one of the elements, it had a bubble in it. And that bubble produced a single spike that went off from the bright stars that you could just notice. So they're very sensitive to those kinds of things.
But this galaxy has an M number. Did I miss that?
No, it does
And
not.
Oh, it doesn't.
NGC,
No,
but not
it's,
M.
Oh,
it's a
okay.
Caldwell. It's got a Caldwell number and an NGC number.
Okay.
Okay, here we are looking at some small opportunistic constellations, Delphinus up here, and the Dolphin, and Sagitta, the Arrow, which they didn't even waste a red line on for it, but they missed their chance of the arrow actually looking like an arrow. So these things are, one is right over the Milky Way, so there's a lot of structure in it and a lot of things to look at. Delphinus is a darker, less populated thing, but there's good stuff to look for in that too. And it's good to get familiar with these constellations. These red things down here and here, not Pluto, but that's by M75, so you can find it easily. But these red things are asteroids.
Oh.
So on my planetarium thing, if I put the cursor on there and I click on it, this is a screen capture, so it won't do it, but it'll tell you what it is and about it and stuff. So.
Mr. President, if you could expand this picture, if it were, don't do it, but if it were widened and that concave horizon, you'd get a big, huge fisheye view of the whole night sky, wouldn't you?
Yes, if it would contract down to a complete circle if I expanded like that.
But we wouldn't be able to see as many individual stars. It'd just be a mishmash, wouldn't it?
You'd see the brightest stars. The fainter ones would fade away. If I took the cursor on this planetarium program and I, put it down here on this horizon, right-clicked it and drug it up here, then the horizon seen here would be flat.
I don't suppose things on that horizon we're looking at represent anything, do they? That's not the
No,
basic.
they're just as a generic horizon.
Okay, gotcha.
This program has the feature of I can go out and I can take pictures of my horizon and I can put that data into this planetarium software, but I've never deemed it worthwhile doing that.
So you downloaded it from Sky and Telescope magazine?
No, this
No.
one is comes with the software. This is what is this? This is the Sky 6 from Software Bisque.
Gotcha.
Now, this is a simple star hop that was pointed out in Sky and Telescope, Altair to Vega to the lozenge. So you start at Altair, you go through Vega, and you come down here. This is the circlet of Draco. This is what they call the lozenge.
Oh,
The
that's
head
what
of the
they call it.
dragon.
Yeah, the head of the dragon.
Sounds like a foreign
So
movie.
these are tricks called star hopping to find your way around the sky with your naked eye, or with a telescope, you can cruise along these ways. But Altair is bright, easy to find. Vega's bright, easy to find. This one is not bright, and so you use this star hop to figure out how to get it when you want to find it.
It looks like about a third of the hop from Altair to Vega. Looks
Right.
like a third. To go
So you
from
take-
Vega to the circlet, it's
Yeah.
about a third of that distance.
Yeah, so in your mind, you break this up into 1/3 lengths like that, and then you go that length again to
Right.
get here.
There it is.
Yeah. Now, if you're lined up with one of the axes, declination or right ascension, you can go to Altair and you can just simply move the scope by its field of view. You measure what the field of view is, and you move the scope. So first you put Altair on one side, right, just as it's going to disappear out of the field of view, and you move the other way till Altair goes out the other side, and then you moved your scope 1 degree. So you can do star hops that way, 1, 2, 3, 4, 5, 6 degrees. Now I'm just arbitrarily giving them numbers, but you can do that with a scope too, and it's a way of finding easy things that might be.
That's a good one.
So this is goodbye to Sushin Shan.
Atlas.
This actually is today, October 13. I took a picture with my handheld iPhone, and it was really quite bright. A few days later, let's see, on Friday would be right about here. I was at the zoo and I could not find the comet visually with my eye. It had gone, it was up here in the darker part of the sky, but it had become very faint.
Yeah, I think it was about 31 degrees on Friday.
Right.
Yeah.
And
So
to
and
star
here's-
hop to the comet, I used those 2 stars there that look like little eyeballs.
those ones.
There, yeah, they're that arc of stars at the bottom of Ophiuchus.
I
Okay.
couldn't see those.
So this
Yeah.
arc.
Yeah. That's what I used at Westmont to show people. And
Tom showed me
we were
those
just
about-
hanging
about
out on the deck, and I just loaned people my binoculars. It was really nice.
I had trouble with that Friday. I had a guy come out and just naked eye. He says it's right there. And I
Yeah.
went, where?
Our old eyes don't work so well.
No, no.
So I was my markers are Arcturus and Venus, both
Mhm.
easy to see. And then back here when I took the picture, that it was right in the middle between the two.
Yeah. Yeah.
Now I
Last
just
week.
form a right triangle here and then
Mhm.
Arcturus.
Oh, okay.
But I'd look right at it and I couldn't see it, so I knew it was there.
I wanted
Well-
to take an image, but I got a really good view. Tom and I got a really good view through my scope, the little 6-inch, and it was pretty nice.
Yeah. Yeah. And
Where-
Martin
where did
pulled
you
it
have
in with
it
this
set
little
up?
telescope at Westmont.
Westmont, okay.
Yeah.
Martin
Spaceweather.com
was up
had a
on the
really
deck.
good picture somebody took of just the coma,
Mhm.
Yeah.
showing a whole bunch of fountains and stuff coming out of it. A lot of
Yeah.
activity.
Oh, I heard about that.
Read tales, huh?
Yeah, the big yellow ball there obviously is our sun. As it's going around, it's shedding its dust tail, which is the stuff blowing off and marking its orbit. The anti-tail is dust that it's shedding off that's not getting blown off. I guess it's coming off somehow, but it's staying in the orbit of the comet, and it's generating a new generation of meteor showers on this as we pass through the orbit at some point. And the ion tail is blown straight out by the solar wind.
Yeah, I don't think we ever passed through the orbit of this comet, but
Hmm.
If we did, there'd be a radiant, right?
There would,
yeah,
for someone.
yeah.
Okay. Wonder what they'd call it.
Depends what constellation it seems to come out of.
Yeah, that's right.
Right. Yeah. Yeah.
Well, you
So-
know, we've had a number of comets go by us over the last few years of doing this show, and are they all gone yet still in the solar system? They're just out beyond Jupiter. And,
Oumuamua is gone for good.
well, that's not,
Yeah.
that wasn't a comet. I'm talking about these comets.
If it had volatiles still on it, it would be would have been a comet.
And a few years ago, Ron, we had Neowise. That was pretty nice.
Yeah.
I think
Okay.
this one's a little better, though. What do you think, Chuck?
Yeah.
Yeah. Okay.
That was
And
also a NASA
also, you know,
program.
speaking of meteor showers,
Hmm.
the DART mission rammed into Dimorphos, you know, that little
Yeah.
asteroid.
Oh, yeah.
And in something, I'm getting numbers 3 and 7, but I don't remember if it was 73 years or 37 years. That debris should be reaching the area of our orbit, and we might get a new meteor shower from that.
Vengeance.
That'd be weird.
Yeah.
Well, we sent another probe out there to see what happened in the long term for Dimorphos.
Yeah. Hera.
What's that?
Hera is the name of the probe.
Okay. Now
No, it's
this is a picture taken by Adam Block,
Wow.
Mount Lemmon. It clearly shows the ion tail and the antitail. So we're looking along the plane,
God.
in the plane of the thing, and it gives it the appearance of a tail going down toward the sun, but it's actually in the background.
What causes the anti-tail?
It just sloughs off material.
Oh.
Material, it doesn't, every single particle doesn't come off with an impact and get a direction like a billiard ball. They all scatter off each other, or a lot of them do, and it just leaves a debris trail in its orbit.
One way you can think of this, Tim, is if the comet had a wide fan tail, as we go through the plane, you could see the fan on both sides of the comet.
Oh.
But in
And
this
Ju-
case, it's not so much a fan as two separate streams of debris, one of which was more affected by the solar wind than the other.
Wow.
I guess what I'm misunderstanding here is it's not the comets. It's not actually going down here. It might be traveling the opposite direction.
It is, yeah.
Okay.
It's heading out.
Okay.
Yeah.
So it's not like a bow shock. This is something
No,
that's going
it's
through
not a
the
bow shock.
Got it. Got it.
It's a similar effect to the Gegenschein or the, what is the other one you see in the evening?
Zodiacal light?
Zodiacal.
Yeah, zodiacal light. Yes, exactly. Thank you.
So, Jerry, did Adam shoot this from Mount Lemmon?
I believe so. Yes.
So that would make those mountains, they're the Tucson Mountains west of town.
Yeah.
Okay. Wow.
Does the tail of a comet, when it's involved, what we're looking at here is not the anti, or it'd be curved, right?
No, this is the antitail right there.
Oh, it is. I thought it
Yeah.
was beyond
It's
the
curved, but it's curved in the plane.
But is there something familiar or similar to our auroras that happens with that solar wind that shoots the tail out?
That's the ion tail that you see,
Yeah.
the blue tail.
Okay.
And often you see green. It's the same kind of thing, fluorescence.
Okay, but a lot of it is stuff that comes off the comet.
Yeah, all of it is.
bombarded by
All of it
protons.
comes off the comet.
Okay.
Wow.
Wow.
I don't know if you remember Hale Bopp, but I remember reading, you know, when it was at its peak and had a huge set of tails, that you could take all those particles in the tails and they would just about fit into a suitcase.
Oh, man. They've gone out and tried to collect some of that stuff and get very little mesh going real fast through the comet's tail. What is this?
This, oh my goodness.
The gravitational lens.
Yeah, this is a very fortuitous gravitational lens. There are, I don't have my cheat sheet here, so I'm going to wing it. If anyone remembers what I wrote in there.
I don't.
It is it is a cluster of near objects, near galaxies, with a very strong gravitational lens ability that is lensing 5 or 7. It is lensing 7 galaxies that are farther away, and earlier in the universe. And they're numbered in order of how far away they are. So this is one here, and there's another image of the same galaxy here. And then there's two here, and there's another two somewhere. Oh, maybe not. So then there's a three, a lot of three structures. Probably put this one back together and see what the original galaxy looked like, because you're getting multiple shots of it. Then four is here, and here. Five
And the
is
four,
there.
it looks like 4 is the one that's forming the Einstein cross, because there's 4 of them, A, B, C, D.
Yes. Oh, no, not, oh, there it is. Yeah. Yeah. Anyway, the fact that these are so many things lensed all at once gives us a look back in time at these galaxies. So we can see the evolution of things, and they're very hopeful that this will give us a little bit more data on how dark matter is distributed in time.
And I think the unique thing about this one is that the distribution of dark matter or mass in general in the lensing group is very uniform.
Right.
And so that really helps them to figure out how the mass is distributed in both in it and in the view behind it.
So it's a rare find, and we will hear more about this in the future.
I just don't understand, gentlemen, why the whole sky doesn't look like that, because there's a lot of space, a lot of distance. I mean, the old Webb is looking at stuff, 13 billion light years away, and how can the world, could all that light go perfectly straight to us? It had to go through and past gravitational things that you wouldn't believe. You'd think we'd get a modeled look like one of those hall of mirrors you had to go through in a circus.
It is getting bent, Ron, but not strongly in many cases.
It requires very precise alignment to get these effects.
Yeah. I know for the asteroid occultations, when they're calculating the effects you're going to see, they actually take into account the gravity of the planets and the gravity of the sun for how the light's going to behave.
Really? But in the middle of this picture, is that it shows 3 dots? Is that three galaxies, or one big one, or is it a black hole?
No, that's multiple galaxies.
Multiple galaxies are doing this. So it takes a big elliptical to pull this off. A galaxy our size wouldn't.
The L up here, the LD, LLL, that's the lens.
Ah. And the cross makes it 4. I wonder why it picks 4. Why don't we get visions of it?
It's just chance alignment, just chance. There's nothing, because you see a lot of them here that aren't 4.
And all those other little dots that look like specks around it, are those distant galaxies beyond that aren't lensed?
I don't know that, but I know there's a lot of stars that are probably in front of it, or they're escaping the major lens effect. There's a general tendency of these blue faint trails to be circular, concentric around the lensing. Yeah. So there's a lot of lensing going on.
Yeah, a lot of the orange ones that don't have labels are probably the foreground cluster.
Yeah. Okay.
Wow. All right, to Mars, right?
Yeah, these are a set of very interesting, odd terrains that are revealed as the polar cap recedes in Mars summer. It's just a bunch of what they call mysterious landforms. They make a lot of good pictures. I'm not going to go through and explain them all, because there was no explanation in the article.
It's really washed out, unfortunately.
Okay.
Oh yeah. This
one is. The one before wasn't. Reminded me of the Huygens drop on Titan. They don't know what we're talking about. It's not a canyon. It's not a mountain. It's not a crater.
It's more like hills and glaciers.
Well, what's different about them?
Carbon dioxide ice.
Is this better?
Yeah, that one we can see.
Oh yeah.
Okay.
Much better.
So this is one.
The white splotches would be ice?
Mm-hmm.
I'm assuming so. It's basically carbon dioxide ice that is evaporating and leaving these colored terrains behind.
The dry ice.
Now, back in the when I was a little kid, when they thought there were canals on Mars, they pointed out that there was clearly life on Mars because in the what is it, the winter times? Oh no, when the polar caps melted, certain parts of the planet got darker, which was supposed to be the green algae and stuff getting water and becoming darker. So back in the back of my mind, I have high hopes for these dark green areas. But like most photos, you don't know how this has been retouched. So you don't know if the color is a true color or not. You'd have to see the original data.
You can really see the layered terrain on the lower left there. Oh, and
Yes.
here too.
Yeah.
Wow.
What was the sci-fi movie with Arnold? It was called Total Recall, right?
Total Recall, yeah.
At the very end, they terraformed Mars in about 4.5 minutes.
Yeah.
About 30 seconds. And then the wind died down. All of a sudden, it was calm summer day with clouds and birds and everything.
Yeah. I wish they'd land on or do something with Olympus Mons or something about a mountain that's 15 miles high that would excite me, especially
No
if it was
flat
on that.
spot for landing.
What?
No flat spot for landing.
Mhm.
Really?
Maybe in the caldera at the top.
Yeah.
Oh, it's a big volcano. Didn't
Yeah.
know. Wow.
This one shows very hexagonal structure, typical of our permafrosted areas up in the polar region in Alaska, where the plains of mud and stuff freeze and refreeze. It leaves these kind of patterns behind.
Really?
Hmm.
What seems to be a round anomaly in the middle of sand, dirt, desert, whatever. Suppose it's a crater?
Yeah,
Dirt
we have a
and
lot
ice.
of information to gather. Someday we'll have explorers up there hiking across this stuff.
But this is from 2 European orbiters?
Yeah, one's an atmospheric studier.
Sounder.
Okay.
Hmm.
And Perseverance's history. Oh, there's the sun in purple.
Now the sun, yes, this was taken in ultraviolet, I believe. The sun has produced a very bright flare here. What is it, an X level flare? X1.
X9.
Oh, is it 9?
Yeah.
I thought, okay. Anyway, this did cause some disruption here on Earth, some noticeable auroras. We got auroras down to Lake Kachuma, as
Did
we
we?
showed last week.
Wonder why that's not on the Key 3 news.
No, they seem to skip over that.
I guess they do, don't they? Yeah.
Now let's see if I can get the
Got a quarter hour to go, gentlemen.
don't panic.
I'm not panicking.
Yeah, leave that to me. I'm the president. I'll panic.
You could talk about dark matter and Dr. Veltman. I got a feeling you feel like he does, Jerry.
Oh, that's not, I'm in Word. That's right. I gotta be in.
Are we
Mail.
on YouTube? I guess we are, aren't we, right now?
Yes, but unfortunately I still can't chat with people on there.
Wonder why that is.
My inability to make the chat work.
Okay. Well, my friend Mike Hardwick discovered us recently. He owns 5 scopes. Here we go.
Oh, wow.
Oh, this
So
is
these are sunspots, high resolution sunspot. You see the material in the prominences?
Yes.
It's not me that's flipping the thing. They're doing that. The material is going down as the prominence, the magnetic field line goes up. So here it's going up, it's dragging material with it, but the material quickly falls back.
Well, can I ask a stupid question? But it just dawned on me. Are there any atoms per se on the sun, or is it all just free-form electrons and protons?
There are all the components of an atom. It's like an IKEA furniture kit, but it's all the particles, including the nucleus, the electrons, but they're so high energy that they're not bound to each other.
I hope it's better than IKEA.
Yeah.
So,
But there are nuclei there, Ron. There is like
Yeah.
iron nucleus, but
Right.
but without most of the electrons.
But all the fusion furnaces down in the middle,
yeah.
far
So
from,
the
and yet
new elements, but they can't capture once the nucleus is made, say an iron nucleus. That nucleus has to work its way out of the sun in order for things to be cool enough that it can stably acquire electrons and become what we determine to be a complete atom.
and then they're hurled toward the earth.
The sun boils these things off and hurls them out in every direction, 4 pi steradians, all around.
Yeah.
Right.
And sometimes the earth happens to be in the way of these particles, but the sun produces a wind that comes off at all surfaces and heads out in all directions.
And it's mostly hydrogen and helium nuclei, primarily hydrogen nuclei,
Right.
so protons.
So just protons. Where do the
Yeah.
electrons go?
The electrons are there too. Some of them find protons and become hydrogen atoms. The moon is subject to the solar wind like our magnetic field is, but it's referred to as proton bombardment. And when you want to simulate what is going to happen to engineering components on probes that we land on the moon, you subject them to proton bombardment in a reactor. And that simulates what goes on with long-term expansion or exposure to the solar wind.
Oh,
So when the first astronauts went up there, I think they went over, they had a bolt cutter. They landed near one of the surveyors, and they cut off cables and different pieces and instruments and brought them back because they are valuable as engineering thing. We need to know what kind of insulators turn to powder and become ineffective over time. So we need to engineer our materials to withstand that environment. And it's hard to simulate it here on Earth.
but I'm imagining that coming here from the sun, a lot of those protons and electrons get together and they arrive as atoms, wouldn't you think?
Some of them do. Some of them arrive as ionized atoms. That is, they may have an electron, but the electron is in a very high orbital.
That doesn't mean anything about the neutrons. Where are they?
The neutrons are in the hydrogen doesn't have any neutrons. Helium has neutrons. Well,
And deuterium would, but they come in the form of the nucleus, so
Yeah.
they're still bound.
Yeah.
If you had a proton all by itself, it would probably decay before it got here.
Yeah. A neutron by itself has a half-life of 15 minutes.
Really?
Yeah. So it decays apart into a proton and an electron and a neutrino.
They're held together by the weak force or the strong force? Is
Strong
that
force.
strong force? Wow. Okay, so that's not a prominence. That's just
This is a prominence.
oh, that is a prominence,
Yeah.
but it's not
Film is
curved.
not being reversed. This is showing them as they are.
Got it.
So let me see if I can get another one here.
Wonder how the Parker probe is doing.
Parker probe is out by Venus, and it just got hit by a coronal mass ejection that also hit Venus. And it's going by Venus to get a change in its orbit so it can go really, really close to the surface of the sun on the next pass.
And it keeps that barrier on it, that shield pointed toward the sun, doesn't it?
Yeah. Oh, this is a good one. A waterfall prominence.
Yeah.
Waterfall. Okay, so this is not part of the magnetic field we're talking about. That
No,
double.
this is the magnetic field. These
Oh,
are
it is.
magnetic field lines that loop out. See, it's a loop of magnetic field. And
Ah,
the stuff gets real hot and it blasts up here. And the magnetic field makes all these ions in their path align. And that reduces its degree of randomness, which lowers its temperature and makes it fall back into the sun.
but do these create the sunspots? The black.
Where they go through the surface, where the magnetic field line goes through the surface, that's where a sunspot is.
Aha.
Potentially.
Right there, there'd be a sunspot.
So that's different from a corona. And there's another
The
phenomenon.
corona's that background glow you're seeing out
That's
there.
Yeah.
ring, okay, but isn't there other ejections that aren't considered prominences?
Well,
Well,
if the
there's-
prominence gets detached and comes flying out, then it's a coronal mass ejection.
Yeah. And
Okay.
then there's flares.
Now, where's the waterfall in this?
See where it's right in the middle where it's kind of falling down toward the sun?
It's not water.
Oh, yeah, okay,
See
Gotcha.
that? This
I
is
got you.
down and this is up.
okay.
Wow.
And here you can see it's moving along, well, a moment ago, you can see it's moving along the magnetic field lines.
Yeah.
The magnetic field on the sun is very strong.
You know, you got to realize that scientists probably are wondering, I wonder if the same thing's going on the surface of Betelgeuse, or is it a totally different ball game, a huge mess?
It's got
Oh.
similar things, but some of the stars are very, very active. And some
Well,
of the
we-
stars, like the big ones, like Betelgeuse and stuff, they're very tenuous at the surface.
Yeah,
Well-
you know, that you consider that, Ron. It's Betelgeuse would hold something like 1 billion of our sun, but it only has like 15 times the mass of the sun.
Well, lately it's been undulating and blobbing out, and it's not even
Yeah, it's very
spherical.
turbulent.
God, I can't imagine what that must be like. And they don't know if there's exoplanets around Betelgeuse?
I haven't heard about that.
Yeah, they haven't seen any. It's tough when you've got an active star surface to pull
Yeah.
out the data.
Also, if you around one of these things, geez, the name escapes me. TRAPPIST. The sun is a small red sun, and it does produce flares, and some of these flares are extreme coronal mass ejections, and they actually would sterilize the planet unless the planet had a super strong magnetic field.
Well, Proxima is the same way, isn't it?
Yes, it's similar.
Yeah.
Red dwarfs and red giants. Well, this is old sun. Which are the stars that last forever or last a long time? That would be red dwarfs
Mm-hmm.
or
Low
some-
mass.
Yeah.
What
Okay.
is that down there, Jerry? It says James and Chips.
That's the guy that made the pictures. That's his handle.
Yeah.
God, how do you get this live? I mean, he just took he just took a film, huh?
Yeah, video, yeah.
The video. God, that's unbelievable.
With an H alpha. And it looks like he composited a separate image of the sun.
Yeah, there's a big change in brightness. That's why you get that yellow rim right around here.
Yeah,
Yeah, it's most likely a composite.
it's something else.
There's a sunspot right there.
Yeah.
Ah. Now the Parker probe is going to come in, what, 3 million miles from the sun? That's about 3 times the width of the sun, isn't it? Out. Isn't the sun 800,000 miles across?
Yeah.
So about 3 times its diameter out. We're going to have a probe that could get hit by one of those prominences and totally destroyed. But I imagine The odds are
Good.
slim.
They're made radiation hard, so they can take it
Ah, really?
up to a certain point. They did the same thing with Jupiter. Jupiter's magnetic field is very strong and it traps a lot of radiation. And so when the thing swings in toward Jupiter, it has to withstand high radiation levels. We have our Van Allen radiation belts around the Earth, which we have to avoid when we're launching satellites. And there's what's called the Atlantic anomaly, which is not a belt, but it's like a area of high radiation that's sort of static or dynamic, I guess, steady state.
You know, Jerry, it amazes me when you see these magnetic lines around the sunspot. It's like when we used to, as kids, take the magnet underneath a piece of paper with iron filings.
That's exactly right. That's and what you see here are temperature differences. Where the thing's highly aligned, it's darker because it's slightly cooler. Because random energy is heat, and the magnetic field lines reduce the randomness slightly, so it appears cooler.
That's as fascinating as can be.
Okay, well, that's it for today, I think.
Well, I got to tell you, here's the problem I'm wrestling with in my brain. I'm wondering if it's crossed your brain that come December, which is a couple months away, we're going to have our first big Christmas party on the 13th, Friday the 13th.
It's not our first, but
years.
Since COVID.
Yeah. And part of the deal is to come up with about a $10 to $20 gift for an astronomer. And I finally figured something out. I'm not going to tell you what it is, but I know what I'm going to get. I may have to mail order it, but it's not a telescope, obviously. Those suckers you already have, and they're really expensive. But
well, it's a white elephant gift. You can just pick something around the house that you've always wanted to get rid of.
Oh, is that what the deal is?
Yeah.
And I think we're going to do one of those
gift.
things where you can steal a gift and,
But it's got to be worth about $15.
well,
depending
it's
on
just
who's
nothing
looking at
super expensive is the
Yeah.
idea.
All right. Well, how many of you met our speaker for November 1st this past Friday night out at Westmont?
Oh
Yeah,
yeah.
she was there.
Oh, yeah.
Yes,
With a whole bunch of students.
And do you know what she's going to be talking about? Her adventure in northern Chile, doing something about the cosmic background.
Measuring the cosmic microwave background. Yeah.
Okay, that's going to be interesting. That's a couple of weeks away. And then, you know what's happening 2 weeks from tomorrow? It'll all be over. Actually, it'll just be beginning because he's not going to.
Speaking of the gift exchange, Ron.
No, I'm talking about the election.
I know. But speaking of the gift exchange, Joe Doyle made a couple of cloud filter eyepieces once. Okay, what he did is he took 35 millimeter film cans because they're just about the right size to fit in an eyepiece. And he got a couple of lenses that acted like little magnifying glasses, and he put them in the cap. And then inside he suspended a slide of a galaxy, a slide film piece of a galaxy. So that if it was cloudy, you could stick this in your telescope and still look at a galaxy.
Yeah. And you didn't have to use star hopping to find it.
Yeah.
You know the globes that we all saw of the Earth?
Yeah.
Would spin. Do they have a similar sphere of the sky that you can buy?
Yeah.
Sure.
Well, I don't happen to have one kicking around the house, but
Edmund Scientific used to sell those. I remember back in the 50s. And also a popular gift at the exchange is a small box of See's candy.
Oh yeah. Oh,
Or lottery tickets.
Yeah, but the See's candy has gotten really expensive lately.
boy,
yeah. Well, because of the added, I guess, what are we going to have? Appetizers before the big meal on that night out at the Timbers. I'm not going to eat for 2 days before I show up. Hey, gentlemen, that'll do it for episode 191. Join us again here next Monday morning for the SBAU Astro Hour, now 3.5 years on YouTube. Try to make our Friday, November 1st general meeting for Westmont Astronomy Professor Jen Ito. Thanks, everybody.
Thanks, Ronnie.
Love it. Appreciate it.
Thank you.
Bye.